All right, we're going to look at isotopes. Remember, isotopes are when we have an element that's got a varying number of neutrons, right? So let's take a look at how you calculate the average mass when this is happening. So I'm going to make up an element. I'm going to name it Kg. This is an invented element. Those are my initials. And I'm going to say that there's four isotopes of this. There's Kg 15. There's Kg 16. There's Kg 17, and there's Kg 19. Okay, so remember, this number represents the mass, okay? And then you're going to, at somewhere, need to know about abundance. And abundance is how common or how rare it is, the amount of that element that exists. So let's say Kg 15 has an abundance of 2.2%, and Kg 16 has an abundance of 90%, and Kg 17 has an abundance of 5%, and then that's going to leave Kg 19 of an abundance of 2.8%. Okay, so depending on the question you're given, sometimes the only mass you're given is right here at 15. Sometimes it might give you a more accurate mass, and maybe it's 14.99, and the 16 is actually 15.99, and 17 is actually 16.99, and the 19 is 18.99. Okay, it doesn't matter. Either way, you've got a mass in some way, shape, or form, and you have an abundance. So we're looking for what's called the weighted average. So when we're looking for the average mass here, it's actually weighted. And that means that not all of them carry the same weight. They're not all equal, right? So what we're going to do is we are going to take all four of these and we're going to string them together. So the way you want to do that is we're going to set up as many brackets as we need to fit all of them. I'm regretting choosing 4. Okay, let's write it this way. We're going to set up brackets for all 4 of them. And we're going to use multiplication. We are going to multiply. Let me erase this because I don't want it to confuse us. We are going to multiply for each isotope the mass times the abundance as a decimal. Okay, so you need to turn that percentage into a decimal. So that means we're going to say 14.99 times 2.2%. And to turn things into decimals, remember we need to slide the decimal 2 spots. So 0.02. And then we're going to say 15.99 times 90%. And 90 as a decimal is 0.9. And then we have 16.99 times 5%. So 5% is 0.05. And then our final one is 18.99 times 2.8%. So 2.8, don't forget, 0.028. Now we are going to add all of these together. So if you're stringing this into your calculator all at once, which I hope you are, you're going to literally put in bracket 14.99 multiply 0.02 bracket plus, and then keep going, bracket 15.99 times 0.9 bracket plus you're going to add all of these together and hit equals at the very end. Okay, so go ahead, take a minute, do that. Okay, so you should have gotten, let's see, I got 16.07. So then I'm going to ask myself, does that make sense? Remember, 16, this is still an average, so it needs to be somewhere in this range, and our range was 15 to 19. So 16 makes sense, and being really close to 16 makes even more sense because 90% of them are 16, so it should be awfully close to 16. Okay, so that's your final answer. Now remember, let me review this. No matter how you're given the mass, sometimes it's just a 15, sometimes a more accurate one is given. You're going to take your abundance and you need to turn your abundance, which is given as a percentage, into a decimal. You are going to multiply for each isotope, mass times abundance as a decimal. Use brackets, multiply brackets, add that to the same situation for every isotope. Don't forget your brackets. Don't forget to add as you go. Your final answer, you need at least 2 decimals, but if it gives you 3, use 3. And that's it. That's how you calculate the average mass of an isotope.